Close your eyes. Imagine a darkness so absolute, it swallows not just the light, but the very concept of space itself. There is no up, no down. There is no here, and there is no there. Nothing exists, absolutely. And then, inside a speck of energy smaller than an atom, the entire destiny of the cosmos is screaming to get out. In less than a trillionth of a second, everything begins. This isn't just a theory. This is your history. This is the story of how we went from a chaotic fireball to a conscious universe capable of asking, "Where did I come from?" Welcome to the Big Bang. 13.8 billion years. It's a number so large, the human brain literally cannot process it. To us, a century is a long time. A millennium is ancient history. But to the universe, a billion years is just a blink of an eye. So, to truly understand the violence and the beauty of what we are about to witness, we need a map, a translator for our limited perception. Let's compress the entire history of the universe into a single calendar year. On this scale, the Big Bang happens at the stroke of midnight on January 1st. The current moment right now, as you watch this video, is the final second of December 31st. Every galaxy formed, every star that died, every dinosaur that walked the earth, and every breath you have ever taken fits into this timeline. But here is the mind-blowing part, the most critical events. The events that defined the laws of physics, created matter, and set the stage for life didn't take months. They didn't take days. They happened in the first fraction of the very first second of January 1st. Let's rewind the clock. Back to midnight. January 1st, 0 hours. We are in the Planck epoch. This is the realm of the unknown. Current physics breaks down here. Gravity, electromagnetism, the nuclear forces, they are all fused together into one single superforce. If you were here, you wouldn't survive. Not because of the heat, though it is 100 non-Ilian degrees, but because the laws of nature, as you know them, don't exist yet. Scientists call this the singularity, a point of infinite density. Imagine taking all the water in Earth's oceans, every grain of sand in the Sahara, every star in the Milky Way, and crushing it down until it's smaller than the period at the end of this sentence. That pressure, that heat, the universe is a caged beast waiting for the lock to break. And at $10, negative $43 seconds, the lock breaks. Gravity separates from the superforce, and instantly, the universe expands. But expansion is too weak a word. This is inflation. In less than the blink of an eye, the universe doubles in size, then doubles again, and again, and again. It happens faster than the speed of light. Wait, you might ask. Nothing can travel faster than light, right? Matter can't travel through space faster than light. That's Einstein's law. But space itself? Space can do whatever it wants. And right now, space is stretching apart faster than anyone thought possible. An area the size of a proton swells to the size of a grapefruit in a fraction of a second. The universe goes from microscopic to macroscopic. But this violent expansion leaves scars. Quantum fluctuations, tiny ripples in the energy field, are stretched out across the cosmos. Remember this. These ripples aren't just noise. They are the seeds. The seeds of future galaxies, the seeds of us. As inflation slows down, the energy dumps into matter. The universe is now a seething soup of quarks, gluons, and electrons. It's called the quark-gluon plasma, but a war is brewing. A war for survival. For every particle of matter created, a particle of antimatter is also born. They are twins, mirror images, but they are deadly enemies. When matter meets antimatter, poof, they annihilate each other instantly, turning back into pure energy. By all logic, the universe should have ended right here. Matter and antimatter should have cancelled each other out perfectly, leaving a boring, empty universe filled with nothing but light. We shouldn't be here. Stars shouldn't exist. But something strange happened. A glitch in the system. For every billion particles of antimatter, there were 1,000,001 particles of matter. Just one extra survivor. Why? We still don't fully know. It is one of the greatest mysteries in physics. But that tiny imbalance, that 1 in a billion chance, that's enough. As the antimatter died out, that tiny remnant of matter was left behind. That leftover dust is what made every star, every planet, and every atom in your body today. We are the lucky survivors of a cosmic massacre that happened in the first second of January 1st. Let's jump forward. We are now 380,000 years past the Big Bang. On our cosmic calendar, it's still early morning on January 1st. But if you were here, you still wouldn't see anything. The universe is a fog, a thick, hot, opaque soup of particles. Light is trapped. Every time a photon tries to travel, it crashes into a loose electron. It's a cosmic pinball game that never ends. The universe is a prison of light. But then, the temperature drops. It cools down just enough to about 3,000 degrees Celsius for something magical to happen. The first atoms form. Electrons finally slow down enough to be captured by protons. Suddenly, the fog lifts. The prison bars are broken. Light is free to travel across the cosmos for the very first time. That first flash of light? It's still traveling today. We call it the cosmic microwave background. It is the baby picture of our universe, the oldest light we can ever see. If you turn on an old TV set and tune it to a dead channel, you are watching the Big Bang in your living room. But after that flash, the lights go out. We enter an era known as the Dark Ages. For hundreds of millions of years, there is nothing but silence. On our cosmic calendar, this darkness lasts from January until May. Imagine that. 5 months of total darkness. No stars to light the way, just endless clouds of cold hydrogen gas drifting in the void. It seems like the universe has gone to sleep, but in the dark, something is hunting. Something invisible. Gravity. Gravity is patient. It's weak, but it is relentless. It finds tiny clumps of gas imperfections left over from the Big Bang, and it starts to pull. It pulls dust into clumps, clumps into balls, balls into massive spheres. Inside these spheres, the pressure is building, heavier, hotter, tighter, until the temperature hits 10 million degrees. The universe holds its breath. The atoms are crushed together so hard they fuse. Nuclear fusion begins, and then let there be light. The cosmic dawn has arrived. These aren't stars like our Sunday, these are monsters. Hundreds of times more massive, millions of times brighter. They are the population 3 stars. The ancestors of everything we see today. They burn blue, hot, and fast. They live hard and they die young. But their death is the most important thing that ever happened to us. Inside the bellies of these first stars, alchemy is happening. The Big Bang only created hydrogen and helium. Boring stuff. You can't build a planet out of gas. You can't build a human out of gas. You need carbon for your cells, oxygen for your breath, iron for your blood, calcium for your bones. They were forged here, in the nuclear furnaces of these dying stars. When they exploded, They scattered these seeds of life across the cosmos. Every atom in your right hand came from a star that exploded. Every atom in your left hand likely came from a different star. We are not just in the universe is in us. We are, quite literally, stardust brought to life. Gravity doesn't stop with stars. It herds them together into massive cities of light, galaxies. Our own Milky Way begins to form around May on the cosmic calendar. It's a chaotic place, consuming smaller galaxies to grow larger. But for a long time, it's a dangerous place. Explosions everywhere, radiation that would fry any DNA instantly. The universe is building the house, but it's not ready for tenants yet. It will take another 9 billion years of cosmic recycling, generation after generation of stars, living and dying, to create a quiet corner in the suburbs of the Milky Way, a place where a very special, very ordinary yellow star is about to be born, and around it, a small, blue rock. But just as the stage is set for life, a new threat emerges. A threat not from creation, but from destruction. Because the universe isn't just expanding, it's accelerating towards a terrifying end. And on a tiny planet called Earth, a species is about to wake up just in time to figure it out. Fast forward to late August on our cosmic calendar, about 9 billion years after the Big Bang, in a forgotten suburb of the Milky Way, a cloud of gas and dust begins to collapse. 99.8% of this gas rushes to the center to form a yellow dwarf star, our Sunday. But the crumbs, the leftovers, the 0.2%, that becomes us. For millions of years, Earth isn't a paradise. It's a hellscape. Molten rock, toxic atmosphere, constant bombardment. But slowly, chaos turns to order. Rain falls for centuries, creating oceans. And deep in those oceans, chemistry crosses a line and becomes biology. Life explodes. But on the cosmic calendar, things happen painfully slowly. Fish don't crawl onto land until December 17th. The dinosaurs? They rule the Earth from Christmas Day until December 30th. And then, an asteroid hits. Boom. Reset. And us? Humans? We don't show up until 11:52 p.m. on New Year's Eve. We have only existed for the last 8 minutes of the cosmic year. All of recorded history. Every king, every war, every invention, every love story you have ever heard of happens in the very last second before midnight. We are a blink, a flash. But in that flash, we did something impossible. We looked up and we figured it out. But the story doesn't end at midnight. We must look forward, and the future is darker than you think. Remember the Big Bang? The explosion that pushed everything apart? Gravity was supposed to slow it down. Eventually, the universe should stop expanding, or maybe even collapse back in on itself. A big crunch. But in 1998, astronomers discovered something terrifying. The expansion isn't slowing down, it's accelerating. Something is pushing the galaxies apart. We call it dark energy. It makes up 68% of the universe, and we have no idea what it is. But we know what it does. It is isolating us. In a few trillion years, other galaxies will move away from us faster than the speed of light. They will disappear from our view forever. Future civilizations will look up at the night sky and see nothing but their own galaxy. They will think they are alone in an eternal void. They will never know the Big Bang happened. Evidence of our origin is being erased. Eventually, the fuel will run out. Stars will stop being born. The last red dwarfs will fade away. Black holes will dominate the cosmos until even they evaporate. Entropy wins. The universe will become a cold, dark, and empty graveyard. This is the heat death, the big freeze. It seems depressing, doesn't it? A story that ends in nothingness. But wait, look at the timing. We are living in the era of starlight, the only time in history when the universe is warm, bright, and full of energy. We are living in the brief, golden moment between the fiery birth and the icy death. We are the universe experiencing itself. We are the eyes of the cosmos. The fact that we are here, on this tiny rock, right now, able to understand this story, is the greatest miracle of the Big Bang. So, when you look up at the stars tonight, don't feel small, feel lucky, because out of chaos came you.